The search for alien life is one of the most exciting frontiers in modern science, and it takes many forms. From the hunt for Earth-like planets to listening for possible extraterrestrial signals, scientists are relentlessly searching for signs that we are not alone in the universe. Among the most captivating and thought-provoking ideas to emerge over the last 60 years is the concept of the Dyson Sphere. Proposed by physicist Freeman Dyson in 1960, the Dyson Sphere represents a theoretical megastructure that could be built by an advanced alien civilization, one that has reached a Type II level on the Kardashev scale. The Kardashev scale is a measure of a civilization's technological advancement based on its energy consumption. A Type I civilization uses all the energy available on its home planet, a Type II civilization harnesses the energy of its star, and a Type III civilization taps into the energy of its entire galaxy. According to Dyson, an advanced civilization capable of building a Dyson sphere would be able to construct a colossal structure around its star, capturing and harnessing the vast energy output of the Sun. This energy would be used to fuel the civilization's needs, possibly allowing them to support an advanced technological society for billions of years. Dyson's idea for a Dyson sphere has evolved since its inception. The original concept envisioned a solid shell encircling a star, but this design is now considered impractical due to engineering challenges and the vast amount of material that would be required. Instead, scientists have explored alternative forms of Dyson spheres, including the Dyson swarm, Dyson bubble, and Dyson shell. Each of these structures has different implications for energy collection, and all could be designed to capture energy from a star in different ways. 1. Dyson swarm, a large number of solar power satellites orbiting a star, collecting energy and transmitting it back to the civilization. 2. Dyson bubble, similar to the Dyson swarm, but with satellites arranged in a stationary configuration relative to the star, creating a more stable structure. 3. Dyson shell, a solid shell completely surrounding a star. 3. While this would be the most effective way to harness all of a star's energy, it is widely considered impractical due to its immense engineering challenges. Despite the challenges of imagining such advanced technologies, the search for Dyson spheres has become a real pursuit in modern astronomy. Detecting a Dyson sphere involves looking for unusual patterns in the light emitted by a star. Specifically, scientists look for excess infrared radiation, which is the heat emitted by the structure as it absorbs and radiates the star's energy. The detection of a Dyson sphere is made even more difficult because the signals are subtle and can be easily obscured by other natural phenomena, such as debris disks, collections of dust and rock that can form around stars after planetary collisions. Over the years, astronomical surveys such as Gaia, the Wide Field Infrared Survey Explorer, WISE, and the 2-micron All-Sky Survey, 2MASS, have made it possible to search through millions of stars for potential signs of Dyson spheres. While the task is daunting, recent research has uncovered a number of promising candidates that may be wrapped in Dyson spheres, or at least exhibit the unusual infrared signatures that could indicate their presence. In a groundbreaking study, Mattias Suazo, a PhD student at Uppsala University in Sweden, and his team led a project called Project Hephaestus. This project aims to detect potential signs of extraterrestrial intelligence through indirect indicators of advanced astroengineering. Suazo's team analyzed optical and infrared data from various satellites, developing a method to identify potential Dyson sphere candidates. The team started with over 5 million objects and carefully filtered out candidates with characteristics that could be explained by natural phenomena, such as nebulae or stellar activity. After narrowing down the candidates, they found 7 compelling sources that emitted clear mid-infrared radiation that couldn't be easily attributed to known natural sources. However, while these candidates showed promising infrared signals, the researchers acknowledged the possibility of natural explanations. One such explanation is the presence of warm debris disks, clouds of material created by planetary collisions. These disks can produce excess infrared radiation, which could mimic the signal that we would expect from a Dyson sphere. Despite this potential for natural causes, Suazo's team remains optimistic that the candidates they've identified warrant further investigation. At the same time, another study conducted by the International School for Advanced Studies in Italy found 53 star candidates that showed similar mid-infrared excesses. While these stars are still being studied, the researchers again warn that extreme debris disks could be a possible explanation for the unusual infrared measurements. The biggest challenge in the search for Dyson spheres is ruling out all natural explanations before concluding that the signal is due to artificial structures. As David Hogg, a co-author of the Italian study, explained, such rare natural phenomena like planetary collisions could be the cause of the infrared excesses seen in these stars. Only by ruling out these less exciting explanations can scientists confidently move forward with the investigation. To confirm whether any of these stars are indeed surrounded by Dyson spheres, the next step is further observation. The James Webb Space Telescope, JWST, the most advanced infrared telescope ever built, will likely be the key instrument to gather additional data on these star candidates. With its unprecedented ability to detect faint infrared signals, the JWST could help scientists confirm whether these stars are indeed surrounded by artificial structures or if the observed infrared signatures can be explained by natural causes. If the detection of a Dyson sphere were confirmed, it would mark one of the most profound discoveries in the search for extraterrestrial intelligence. A Dyson sphere would suggest the presence of a Type II civilization, a species capable of harnessing the energy of an entire star, something that is far beyond our current technological capabilities. Such a discovery could provide insights into the development and sustainability of advanced civilizations. It could also raise profound questions about the future of humanity. Could we one day build our own Dyson sphere to meet our growing energy needs, or will we eventually be replaced by other, more advanced civilizations? In addition to its implications for the search for extraterrestrial life, the idea of a Dyson sphere touches on many technological and engineering challenges. The materials required to build such a structure would need to withstand extreme temperatures and the intense radiation of a star. The energy transmission systems would have to be capable of sending vast amounts of energy across enormous distances. Additionally, the stability of such a massive structure would be a concern. How would a Dyson sphere maintain its position around a star, and how could it be protected from the forces of gravity and radiation? Theoretical studies of Dyson spheres have become an important part of astroengineering research, and their implications go far beyond just the search for alien civilizations. If Dyson spheres exist, they could offer clues about how highly advanced civilizations might evolve and how they could sustain themselves over the long term. The search for these structures also offers a valuable opportunity for scientists to refine our understanding of the future of energy production, space engineering, and planetary systems. While the discovery of Dyson spheres would be groundbreaking, it would also raise many new questions about the nature of extraterrestrial life and the potential future of humanity. Could Dyson spheres be the key to unlocking a new era of interstellar energy production? What other forms of astroengineering might exist out there in the universe? The search for Dyson spheres is just one piece of the puzzle in our quest to understand the universe and the possibilities that exist beyond our home planet. As the search continues and new technologies like the James Webb Space Telescope come online, we are closer than ever to uncovering the mysteries of these alien megastructures. Whether or not we find evidence of Dyson spheres, the pursuit of such discoveries brings us one step closer to answering the most fundamental question of all: are we alone in the universe? Only time will tell, but the journey is bound to be filled with discoveries that will change our understanding of the cosmos forever.